Good afternoon, everyone. Thank you for joining us for today's webinar. The topic is going to be blending parametric and freeform modeling for precise and flexible bridge design. You're joined by myself, Jalpish Patel, and my colleague, Alex Barbone. And today we'll cover in-depth discussion on prisms. It's a key new functionality, another way of modeling within ALLPLAN Bridge. So key functionality for today's webinar is going to be the freeform parametric modeling. This is one more method available to you within your toolkit for modeling bridges. The first form that we did were girder members. Again, we had a cross-section member that we extruded along an axis to create a 3D component. And then earlier this year, we also included precast girders, defining a localized axis between two reference points to create precast girders which are chorded on a curved alignment. Now we have added the functionality of freeform parametric modeling. This helps with some really intricate detailing of abutments and substructure, which usually happens as a post-process in your CAD platform or your 3D modeling platform. But we want to make sure that we could connect this parametrically to our model, which helps us make our change management smooth and easy. But on top of these functionalities, we have also added additional ones that might be of your interest. So please take a look, and we'll also try to follow up with some detailed webinars similar to this one. One of these topics is analysis. Now we have integrated Midas into ALLPLAN Bridge, so we could transfer the model that's being generated in ALLPLAN Bridge directly to Midas to make sure that we could create a centralized model that is driving the analysis model as well as the plan production. Then we have attributes. The updates with the attributes is we want to make sure we could organize it and have a method of standardizing the data that is being populated within your BIM model. So we have user-defined property sets. This can help you organize what information should be populated in an organized manner. So we've taken a bunch of attribute data and defining a standardization process of how to define it in a way that's easy to access and familiar for your whole firm. So we're creating these property sets to help you create templates of the data that needs to be included for your BIM model. Additionally, we are also trying to help you improve efficiencies when it comes to plan creations from the 3D model. So one of the key functionalities that we have added is the ability to create cross sections by clicking on a surface. This helps improve the plan production process to make sure it's accurately defining some cross sections along a plane that you want to define associated with the 3D model. One more functionality that has been added is Celebri BCF Live Connector. This is really powerful. A big void in our workflow right now for digital delivery is the QA/QC process, and this is going to be a big step in helping resolve that missing link between the QA/QC platforms and ALLPLAN or any of these digital platforms that author the model. So over here we have connected both of these solutions to each other, so that way you could have a seamless communication between the review team and the design team from within their independent platforms, and then track the changes and make sure everything's organized in terms of the communication that's happening between the reviewer and the modeler. Additionally, we have also created a live sync with Lumion. This is again a benefit for visualization and public engagement, not having to regenerate the model. We could use that ALLPLAN model as our central source to again create visuals and explain what we're about to construct in an easy manner. Further, we're improving our construction planning ability within ALLPLAN engineering. So we have created additional assets that can help define these criteria and making sure the construction can be laid out and phased within ALLPLAN before it goes live to reduce risk. So we have added some Python parts and some assets that can help lay out and generate a construction site to simulate the construction process. Additionally, we have added more functionality for open BIM and interoperability. We have improved our IFC 4.3 export, as well as exports to DGN and DWG. This can help with interoperability with your current solutions and making sure that you could deliver in formats that are still recommended within your states and your agencies. So this kind of highlights everything that's coming or that has already come out for 2023. We'll try to cover most of these topics in the next few months in terms of what that functionality looks like, how to utilize it, how it could benefit you in today's workflow. So this is going to be the first of those specialized webinars that we focus on these specific topics. So today's topic is going to be the freeform parametric modeling, and we'll go ahead and showcase how that can be beneficial in your current workflows. So I'm going to go ahead and pass it on to my colleague, Alex Barbone, and he'll show you how to utilize these functionalities that are available now with ALLPLAN 2023. Alex?
For this webinar, we're going to be making use of one of our new example projects within ALLPLAN Bridge 2023. This example project is a precast concrete girder bridge. It has 2 spans, and it makes use of our new free parametric modeling technique. This technique has been developed by creating a new type of structural member within ALLPLAN Bridge. It is belonging to a classification of structural members that we're referring to as prisms, and this new structural member type is referred to as a body. The purpose of this is to extend the ability to model some very tricky interfaces between different components within a bridge project. Our existing parametric modeling tools make it very easy to model things such as piers, bridge decks, and even precast concrete girders. One area that's been tricky for people to model has been interfaces between different objects. And this occurs very frequently, for instance, in, say, substructures, especially at abutments. A lot of the times these abutment objects are constructed of relatively simple shapes, but it is the interfaces between them that pose a specific modeling challenge. So for instance, looking at one of the abutments already in the project, we can see that there is a very tricky interface at each one of the locations where the abutment wall meets the wing wall. Zooming in a little bit here, we can see that the abutment wall is battered for part of its height, and then flat up above the bottom of the bearing seat location. The retaining wall itself is battered its whole height. And of course, this is all coming in at a very specific angle. All of this geometry, this interfaces, where these 2 walls meet up based off of that batter can be a very tricky location to model. So what we've developed is a technique for combining some of the freeform parametric modeling process that was previously only available within ALLPLAN engineering and bringing it into the ALLPLAN bridge environment where we can combine aspects of freeform modeling with our existing parametric modeling. If I take a look at this abutment object within my project navigation window, you'll notice that if I were to select the abutment 1 member, the entirety of that abutment, including the wing walls, are selected. You'll also notice that there are a number of other bodies located within the project as well. Let me change the visual settings here to make it a little bit easier to see what's getting selected when I click on each one of the objects in the project navigation window. You can see that I have selected now just this one body, abutment 01 underscore corner 01. It's just simply a box. It's part of the abutment, but it's been deconstructed down to just a simple box, the location where the abutment extends beyond the diaphragm and where it meets up with one of the other retaining walls. I believe it is wing 02A in this case. Essentially, this whole abutment object, despite the fact that it seems to be made up of very sophisticated parts, is really just a series of blocks that have been connected to one another using various docking points, and then connected to other parts of the project as well. In the end, all of these blocks are then unioned together to form one cohesive object within my project, and then it is this project that I can add some attribute information to, and it's this object which will be brought into ALLPLAN engineering as a single cohesive structural member. This way, all of those tricky little interfaces are resolved immediately simply by unioning the different blocks together. Even after all of these objects have been placed within the project, it's very easy to continue to manipulate them. We'll take a look at just a few manipulations here before we start constructing abutment 02. For instance, I can only select just a single part of my abutment object, and if I need to adjust its dimensions, I'm free to do that at any time. In this case, I'm just going to stretch the height of the retaining wall so that it lines up with the top of the diaphragm here. Of course, now the height of my retaining wall itself needs to be adjusted, but again, it's a simple process of selecting the relevant slider and moving it back into position. I can express some more finite control over the whole object. For instance, I can select just a portion of the overall abutment, and then I can view the properties, and let's say I need to adjust the width of the retaining wall's heel. So this is the foundation, and let's increase that foundation by 2 feet. Close out of this menu, and then I can recalculate the model. Notice how the retaining wall footing has now extended, and it is a little bit wider than it was before. I can also take these objects and perform other operations such as rotating them. This retaining wall has already been rotated, but I can always adjust the value of that rotation by accessing the list of what we refer to as transformations. Apologies, it looks like I misselected there. I want to select wing 01. View its list of transformations. And now I want to change the value for the rotation from 60 degrees, and let's increase it to 85. Now I can return to my 3D model and recalculate the model. And now the angle of that retaining wall or wing wall where it meets the abutment has been adjusted. Throughout that entire process, this abutment 01 object continued to be one whole cohesive object within my project, even though I was able to go in and edit individual parts of it. Let's take a look now at trying to model one of these abutments ourselves. We're going to take a look at the abutment at the other side, and we're going to use the new bodies structural member in order to create a similar abutment as what we have on the left for abutment 01. Let's get started with placing some of the bodies for abutment 02. Just like some of the other structural members, I'm able to simply select the relevant portion of the project navigation window, right-click and indicate a new structural member. I'm going to select a specific cross-section created for the structural member, and I'm going to locate it based off of 2 reference points, not unlike how a link girder is placed. As I zoom into abutment 02, notice that there's already quite a few reference points located within the model. These have been placed within the cross-section for the diaphragm, and they're intended for positioning the body structural members for the abutment. So in this case, I'm able to select those reference points in order to establish the start and end of my abutment. However, I'm not done manipulating it just yet. You'll notice that there's a series of little arrows throughout the body, and I can select any of those locations in order to manipulate some of the cross-section variables. So in this case, the overall height of the body, I want it to extend down to the axis that represents the bottom of my foundation elements. So just like that, I can place a new body member simply by specifying a cross-section and then clicking on 2 reference points to place it, and then afterwards I can carefully manipulate the dimensions of this member, either by selecting those sliders and moving into position, or by adjusting specific variable values within the cross-section. Let's go ahead and add the corner blocks now. We'll create some new body members. And in this case, the cross-section that we want's simple rectangle. So place start and end. And until it's stretched into position, again by manipulating the sliders here, it doesn't quite have the look that we need it to. But a very easy process now to click and manipulate this into position. And then I can always select the object as well. And then in this case, let's set the other values equal to 0. And now I have that object in position. Let's go ahead and add the corner block on the other side as well. So repeat the process now on the other end of the abutment. Again, I want that simple rectangular cross section. We'll just extrude it from one end to another. Then, of course, easily manipulate it into position by selecting the sliders and changing the values by clicking on other structural members already in the project. Then let's go ahead and, rather than manipulate the last two sliders, we'll set those values to 0. Recalculate the project. And we can already see our abutment is beginning to take shape. Let's start adding the members for the wing walls now. We'll get started with the wing wall here on the left of the project. Start by creating our new body member. And for this one, I want to specify the relevant cross section. And I want this one to extend from a docking point and then relative to that docking point. This will allow us to specify the overall length of the retaining wall, and then we'll go ahead and rotate it into position. Let's go ahead and select the corner here, and then we'll specify an overall length of this retaining wall to 35 feet. Cross section obviously doesn't have the correct dimensions within it for this particular location, but again, we can always adjust the sliders in order to match it up with some of the other geometry already within the project. So now I'm just matching it up with various docking points within the adjacent abutment body. Now let's go ahead and rotate this wing wall into position, and then from there we can continue modifying some of the values within the cross section. We'll specify a rotation. May access the properties. So I really only want the Y direction to be free here because I want to rotate it along the Y axis. And we'll change the view here. Now we can see that we can select that rotation axis, and then here let's go ahead and create a 90-degree angle, and this will place it at a right angle to the abutment. Let's go ahead and select the wing wall again, and let's see if there's any values that we should adjust for this member. So let's have a thinner minimum thickness at the top of the retaining wall. And we should probably increase the width of the footing as well. Let's increase that to 10. And calculate. Now we can see it's thinner at the top. The foundation is a little bit wider, but the transformation has still taken effect. Now we can model the wing wall on the opposite side of the abutment. Call this wing 04. And similar process, we're going to select the relevant cross section. Docking point, relevant, that all looks good. We'll specify it starts at the corner here, and this one we'll say is 40 feet. And again, just to show that this whole process can be performed in any order, let's go ahead and rotate the member first. We've still got that Y lock in, so that way it's only going to allow me to rotate along the Y axis. And instead of 90 degrees, let's place this one at 70. So now it's at an angle other than a right angle to the abutment wall. We'll go ahead and specify that the thickness of the stem is 1.5. We'll choose a similar value for the width of the foundation. We'll recalculate. Now let's go ahead and stretch this into position here. All right. Now we can see we've got most of the primary prisms within the model already. There's a few little interfaces though that we're going to want to clean up before going further. Let's finish up the model of the abutment by including some additional bodies to model the chamfer at the location where the abutment wall meets the retaining wall, and then the gap that is currently appearing at their respective footings. So we'll call this abut 02. And we'll create this one from docking point to docking point using that rectangular cross section. And then, like the other objects, we'll stretch it into position using the slider controls. Okay. We'll come along to the other side and finish this. And then one final time, we'll come into here, adjust the sliders as necessary to line it up with the other geometry in the model. My abutment is now modeled as a number of separate bodies, but I want to go ahead and start merging them all together to form just one specific body for the entirety of the abutment. What I'm going to do is take this one abutment, 02 structural member, and then union it with all of the other members. This means that I'm going to end up just with one abutment 02 member that includes all of the geometry combined with these other structural bodies or structural members. So what I want to do here is indicate that these bodies are only used to help me construct another body within the project. In other words, they're just helpers. Their geometry is being used to create, in this case, the abutment 02 body, and I don't need to include the structural members when I export the geometry later on. They're just helping me with the overall modeling process. So for that, I can indicate that all of these structural members have a property called auxiliary. And when this property is enabled, it will indicate to ALLPLAN Bridge that they're just helper bodies that are being used for some of these Boolean operations. So as this is recalculating, it'll just indicate that these are auxiliary bodies, and now we're going to see that they're transparent. So now I can go ahead and select the primary body and then perform the union commands and start joining all of those other separate bodies to it. Again, clicking the primary and performing the union command. And now when I select abutment 02, I can see that's including all of that geometry. And so this is very helpful because now I have one cohesive element that's going to represent the entirety of the abutment. And that's helpful too because if I need to specify any properties, such as what type of material this is constructed out of, then I can indicate one material for the entirety of that structural member. And then as I perform the union command, we'll see that the additional geometry is also going to take on that material property. So notice that all of the geometry that I'm connecting using that union command is also going to be indicate as concrete because now it's all part of one big structural member. So now if I were to select that abutment 02 member again, I can see that it is the entirety of this section. Zooming out a little bit here. And with these auxiliary bodies, there is a setting within the view so that I can decide whether to show or hide structural members that have this auxiliary property enabled. So notice how that there's this kind of bluish grayish hue over some of these. That's because there's still two structural members superimposed over each other. There's that abutment 02 member that's been extended to include the geometry from, in this case, the wing 03 member. I can always turn off the display of those auxiliary bodies, which tends to help clean up interfaces where there are multiple structural members. And now I can see very clearly that there is now just one structural member that's combined to include all of those individual bodies that we've placed. The union tool isn't the only of the Boolean operations that we have. We have two others. One of them is a subtract command. That might be helpful for situations where you need to put penetrations through an existing body structural member. So for instance, for this abutment, we might have some drains that we need to place through the abutment wall, and we can indicate and model this by taking a simple cylindrical body and then performing the subtract command, and then removing that location from the abutment where that drain is going to be located. So I've already created a template, I should say, that will allow me to quickly place a few of these drains. I'm not going to place all of them. We'll just place the first 2 or 3 of them into the project. Let me specify I want reference point to reference point. And then let me use the multiple copy commands to place a few more of these. Now I do want these drains to extend a little bit further. For one thing, they're not extending through the back of the abutments. So one thing that I can set for these body elements is if I were to select all 4 of those new bodies, then I could go ahead and indicate, just like I would with link girders, that there is offsets from the geometric positions. And we'll recalculate. And now I can see that those drains are in fact now passing through the abutment. And let's go ahead and perform a subtract and remove them. There we go. Now all of these Booleans are being stored within ALLPLAN Bridge. It is calculating this procedurally. So at any point I can go ahead and pull up the whole list of Booleans. So these are all the Boolean operations that are performed for abutment 02. So I can see there's been a union command done for all of those bodies that we placed earlier, and now there's a subtraction command for the drains. I can actually directly modify this table. So let me add 2 more subtraction commands, 1 for each one of those drains. So we'll come in here and describe the next operation. So I have the ability to graphically or tabularly enter this information. Switch back to the 3D model, and I also want to change these 4 drains to also be auxiliary bodies. Now after we recalculate, what we'll be able to see are the penetrations where those drains will be located. I can see them passing right through the abutment. The last of the Boolean operations that we have is the slice command, and this allows me to sort of perform a subtraction command, but using a plane to remove a piece of a body. So let me go ahead and change my display settings because I do now want to look at those auxiliary bodies. And there it is. And what I'm going to do here is I'm going to start slicing the retaining walls to indicate that the height of the retaining walls actually tapers over its length. So use the slice command, Let me specify that this member is being sliced. I want to choose, I'm going to slice the wing wall. I'm going to specify the points using docking points. I want to say it's sliced at the face of this wall and then down to that location. Now I can see that it's got a taper to it. Go ahead and repeat that process on the other wall. So again, I'll start the slice command. I'll select the body, in this case wing 03. And then again, I want to indicate that the slice plane is defined by these 3 docking points, and then remove the portion above. And now I can see that it is in fact tapering over the length of the wall, both on the wing wall on the near side and the far side. So now I've got my abutment, I should say, mostly modeled at this point. And while it's mostly modeled, that doesn't mean that the structural member can't respond to changes that are made within the project. I still have the ability to manipulate and change even pretty fundamental portions of my project and have those changes affect even the body structural members. So this is what we mean by having the combination of freeform and parametric modeling, is that we did provide a lot of tools that are more related to freeform modeling, but the whole process of that freeform modeled object is still derived parametrically, which means that if I make changes within the project, such as maybe adjusting some of the variations. So let's go ahead and, for instance, change the variation value for the width of the sidewalk. And we'll change that value from 12 to 14. This is going to affect the overall width of our bridge deck. Since we're changing that value, we probably should also adjust the width of the abutments. That way to compensate for some of the extra width that we're going to be using up here. Let's zoom into the bridge. And with this change in effect, we expect to see that the sidewalk width is going to increase by 1.5 feet, and then consequently we're also changing the width of the abutment to extend 3 more feet out. Those changes are all going to occur parametrically, and even though we freeform modeled portions of the abutment, we're going to see that our model does respond to those changes. It's going to allow us to extend the width of the sidewalk. Our body, since it's attached to those reference points on the edge of the diaphragm, is going to adjust, and we've got some extra width there as well. We can also do things such as adjust some of the transformations that we applied to our auxiliary bodies. So for instance, for this retaining wall, I can go ahead and adjust the angle that this is positioned at. So let's go ahead and we'll select wing 04. I want to view the list of transformations. And let's change this from a 70-degree angle to, let's do 80. We'll return to our 3D model and recalculate. And now we can see that that angle has changed, and my abutment 02 structural member is still being correctly modeled. All of those different operations, including the chamfer at the foundation corner, are all being positioned based off of those parametric relationships I established. And of course, we can even modify the alignment for the bridge and watch as our entire abutment object changes to its new position. So let's go ahead and we'll access the axis plan. And let's change the radius here from 6,000 to minus 2,000. So that's going to be a more severe curve in the opposite direction then. Let's return to our 3D model, and then we will recalculate. There we go. We can see that the entirety of the abutment translated to its new position to account for the change in the axis or the alignment of our bridge. So that concludes our technical presentation for the webinar. So we can see that we now have the ability of combining the existing parametric modeling process within ALLPLAN Bridge and extending that functionality to include tools and techniques that are more familiar and more prevalently used in freeform modeling softwares. So at this point, you're starting to get the best of both worlds, really. I did see that there was one question that was posted to the chat already, and it was related to the slice commands. And the question was, what if the slice plane is curved instead of flat like it was shown in the demonstration? So the slice command is intended to be a simplified version of the subtraction command. And it's simpler because it allows you just to cut an object with a flat plane. But you could always create the type of geometry described in the question using the subtraction command instead. So what you would do is if you've got a curve that needs to be taken out of, say, the top of a wing wall or retaining wall, you could just use an oversized circular cross section and then put that as a body perpendicular to the retaining wall and then perform the subtraction command. So it'd kind of be like the example of the drains going through the abutment wall, just with a larger diameter circle, or whatever type of curve you would need to perform that operation. All right, does anyone else have any questions for us about either the technical demonstration where we focused on the new Prism bodies and those Boolean and free parametric techniques, or any of the new features that JP mentioned at the beginning of the presentation? Can variations be used on prisms? Okay, there was a second question, can you use variations on prisms? Not currently. That is something that we would like to include in the next development of the prisms. You saw me entering values using those sliders to interactively set values for what are the cross-section values, and also entering manually what those values should be. Currently, it cannot accept variation values, but that is something that we are looking at. It was sort of one of the first questions that people asked as they were seeing the feature for the first time. Okay, it doesn't look like there's any other questions that people are posting or entering into the chat. Laura, do you want to know where they can find a recording of this webinar later on?
Yeah, we will actually have it on the website by tomorrow, and you guys should be able to track that down on our website under the recorded webinars.
Great, thank you. And if you do have any questions later on, my contact information and JP's are listed on the slide right now. Feel free to reach out to us if you're interested in seeing any more or have any specific questions that we can answer for you.